All right, so we are given an equation, and that is an equation for force Fx equal to 8x minus 16. Okay, here Fx is measured in Newton and the displacement x is in meter. Okay, and this force is basically acts on a particle. Okay, and we have to draw a graph where Fx in the y-axis and x is in the x-axis, I mean the displacement in the x-axis, from x equal to 0 meter to x equal to 3 meter. Okay, so this is the first question, and once we have this graph, from this graph we have to calculate the net work done by the force on the particle when the particle moves from this, I mean from x equal to 0 meter to x equal to 3 meter. So the next question is to find the net work done. Okay, all right, so to do that, I mean to plot the graph, first let me find all the points necessary to plot that graph. Okay, all right, so first let me build a table. So the first column is x in meter, second column is Fx in Newton. Okay, so from this equation, when x equal to 0, you can find that Fx equal to minus 16. When x equal to 1 meter, you can see that Fx is minus 8 Newton. When x equal to 2 meter, Fx equal to 0 Newton. And when x equal to 3 meter, then Fx is equal to 8 Newton. Okay, so then the graph will be something like this. So here this is Fx in Newton, right, and this is x in meter. All right, so when 0, it is 16 Newton. Okay, 1 2 3, so at 1 it is minus 8 Newton, 0 Newton, at 3 it is 8 Newton. So here are our points. The graph looks like this basically. Okay, so this is 8 Newton. All right, so this is the first part of the question. I mean the force versus displacement graph between x equal to 0 meter to x equal to 3 meter looks like this. Okay, so the next question is, what is the net work done? So the net work done is the area under the curve. Okay, so net work done is area under this graph. Okay, so area under this graph means this part plus this part. Okay, so what is the area for this graph? I mean this part of this graph. So you know this is 0, this is 1, this is 2, and this is 3. Okay, so this part of the graph, I mean this part of this graph, the area of this part of this graph is half times base times height, right? So because this is a triangle, right? So this is a triangle, so area of a triangle is just half base times height. Okay, so the base is this part, and that is 1 meter, and height is this part, okay, and this is 8 Newton, okay. So this part gives us base is 1 meter, 1 meter and 8 Newton. So this is just 4 joule, okay. Let me erase this part and find the area under this part of this curve. So area of this triangle. So here you can see this is again another triangle, okay. So in this case the base is this part, so base is 2 meter, right? This is 2 meter and height is this part, and you can see this is below the x-axis, and the length from here, from this origin to this, is 16 meter, but because this is below the x-axis, then it is minus 16 Newton, okay. So the area of this curve is half times base times height, okay. So half, base is 2 meter and height is minus 16 Newton, okay. So this part is just minus 16 joule, okay. So the total area is this plus this, okay. So the net work done will be this plus this, okay. So the net work done, that means the solution for the second part of this question, B, the net work done is equal to minus 16 joule plus 4 joule, and that is equal to minus 12 joule, okay. So this is the answer for this question.